Hello again and welcome back to Mr. Algebra. For this video we're going to show how to convert slope-intercept form into standard form. And slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. We're going to take this form and rewrite it into this form. So these are both linear equations, but this form can be rewritten into this form, which is called standard form, and it's called ax plus by equals c. X and y are your variables, but you have these letters a and b, which are coefficients of x and y, and then this value c, which is just some constant term. Now when you're in this form, standard form, the a, the b, and the c values, which are these three values here, they must be integers, meaning no decimals and no fractions. That means we're going to have to clear out some decimals or clear out some fractions. And the second rule is that a cannot be negative, and some people kind of have a problem with this, whether a is positive or negative. It doesn't really matter. However, in quadratics, I tend to make my a value, which is my leading coefficient, positive anyway, so I stick with this convention of a not being negative. Now there's only 3 steps required to get it from this form into this form, and the order in which you do these doesn't really matter as long as they're all done. The first one would be clear all fractions. Now if you have decimals in the problem, that would be decimals. Number 2, we would bring the x term to the same side as the y, because if we're starting in this format right here, the x term is always going to be the opposite side of y, so we bring this to this side, leaving a constant term here, which would end up being our c value. And then the third thing is to ensure that the coefficient of x is positive. That just goes back to this rule right here where a cannot be negative. Now I'm just going to make up these equations, but I am going to make them up all in slope-intercept form. So step 1, I want to clear all my fractions. Well, my denominator is a 2. So what that means is I have to multiply everything in this problem by 2. So 2 times y will give me 2y. 2 times negative 5 halves will give me negative 5, and then the x comes along. And then the 2 times the positive 7 would give me a positive 14. So that's the step 1. I've cleared the fractions. No more fractions left in the problem. Now I want to bring the x terms to the same side as y. So x is right here. That's a minus or a negative 5x. So to eliminate the 5x's from this side, I'm going to add 5x's to both sides. So on the left-hand side, I end up with 5x plus 2y equals, this becomes 0, and 0 plus 14 is just 14. And notice how I put the x up front, because that matches my standard form of having ax, which is the coefficient of x, which in this case is 5, up front. The last thing is to ensure that the coefficient of x is positive. Well, the coefficient of x is 5. It's positive 5, so I actually finished this in 2 steps. So this right here is my standard form for the original equation that I had up here. Okay, let me come up with another one where the coefficient ends up being negative. So let's do y equals 1/3 x. Actually, let's make that 2/3. 2/3 x minus 4. Okay, so step 1 is clear all the fractions. Well, the least common denominator is going to be 3, because I only have the one fraction in there. And I'm going to multiply both sides by 3, which means I have to multiply this, this, and this all by 3. So 3 times y is going to give me 3y. And 2/3 times 3 is going to give me 2x. And negative 4 times 3 is going to give me negative 12. So all I'm doing is the distributive property. Step 2, bring the x term, which is this one, on the same side as the y. So I'm going to get rid of the 2x's by subtracting 2x's from both sides. I end up with a 0 here. 0 minus 12 is negative 12. And then since these are not like terms, all I can do is express this as negative 2x plus 3y. And this really looks just like this up here, which is standard form. The only problem is if you look at the coefficient out front, it's actually negative. And this rule, many people abide by this rule where the first term or the first coefficient cannot be negative. And some people will say, well, just turn those around and call it 3y minus 2x. Well, a is considered the leading coefficient, and that's what they want to be positive. That is that coefficient of x. So the way we fix this, most people look at it and go, well, just multiply through by -1, and that's perfectly fine. I like to show it as a divide by -1 so everybody can see that I'm actually dividing each term in this problem by -1. This becomes a positive 2x. This becomes a negative 3y, which turns to a minus, and then negative 12 over negative 1 is a positive 12. So this ends up being my standard form. My next example, I'm going to do it with two separate fractions. So let's say I have y equals 5/3 x plus 7/2. Let's go ahead and do that. So I have two different denominators. So step one, when I clear all fractions, I'm going to multiply this whole thing by the least common denominator of 3 and 2, which happens to be 6. So I'm going to multiply everything by 6. So 6 times y will give me 6y. Now remember, this is 6 over 1. So I'm going to do 6 over 1 times 5 over 3. I end up with 30 over 3 times x. And I'm going to do the same thing here, 6 times 7, which is going to be 42 over 2 times 1, which is 2. And then I'm just going to reduce these. So 30 divided by 3 is 15, and 42 divided by 2 is 21. So I'm done with step one. I've cleared out my fractions. Step two, bring the x term over. So I'm going to minus 15x's from both sides. That gives me a 0 here, and 0 plus 21 is an identity. That's just 21. And these are not like terms, so all I can do is express it as negative 15x plus 6y. And I got to make sure, that's step two, make sure that my leading coefficient, my x term, is positive. Well, it's a negative right now, so I'm going to divide everything by negative 1. And I end up with 15x plus, sorry, let's start that again. I end up with 15x minus 6y, because positive divided by negative is a negative. And then over here I have a positive divided by negative, which is also another negative. So I end up with 15x minus 6y equals negative 21, and this is my final result. Now I'll take a moment to go ahead and show you how to do that with decimals if you happen to have any decimals in the problem. So let's suppose we have y equals 2.06x minus 9.5. Most of the time we're not asked to rewrite these into standard form, but you can do it. But just remember that step one is to clear out the fractions, which in this case we don't have fractions, we actually have decimals. So what we want to do is clear all the decimals. And the way we do that is we look at our two decimals here, and we see which one has the most decimal values, and that's this one right here. And this one right here is measuring down to the nearest 1/100th. So there's our key right there. To clear our decimals, I'm going to multiply everything in this problem by 100, and what that will do is it'll clear all my decimals. So 100 times y is 100y. Now when I take 100 and I times it by 2.06, the effect is the decimal moves 2 places to the right, one for each multiple or each power 10, which is in this case is how many zeros I have. So that ends up equaling 206x minus, and I do the same thing here, multiply here, but I end up having to move the decimal twice as well. When I do that, I end up having to fill an extra 0 in there, so minus 950. Then the next step would be to move the x's all to one side, so I end up with negative 206x plus 100y equals negative 950. And of course the last step is make sure this is not negative, so multiply everything through by -1 or divide by -1. Now here's the shortcut. When you multiply or divide everything through by -1, all that happens is each number changes signs. So you'll see this negative becomes positive, that positive becomes negative, this negative becomes positive, and this ends up being our equivalency.